Hello, and welcome to the Boeing 777 type rating series by Qantas Virtual. Today we're going to be reviewing the hydraulic systems of the Boeing 777. The aircraft used for demonstration will be the Boeing 777-300 ERX by PMGG using FSX. Some basic information about the hydraulic system of the Boeing 777 is that it's the three-system setup. You've got three systems that power different hydraulic functions of the aircraft. This is for redundancy and to prevent overwhelming hydraulic pumps and systems of the aircraft during load use, like for example deploying flaps and using control surfaces or applying the brakes and thrust reversers. There's a few different pressure sources we can talk about here. You have engine-driven pumps, which come from pumps on the actual engines themselves. You have electric-driven pumps, which are driven by the AC system, the AC electrical system of the aircraft. You've got air-driven pumps, which are powered by bleed air from either the engines or the APU, and you have the ram air turbine system, which is deployed in emergencies and provides electrical and hydraulic pressure should the system fail. Now, the hydraulic system provides pressure for numerous systems, which you can actually see here in the ECAS display. You've got power for flight controls, the leading edge slats, the trailing edge flaps, the landing gear, the wheel brakes, the nose and main gear steering, and the thrust reversers. You also will see that there are some redundancies as well, as flight controls are powered by all three systems, and you also have alternate brakes powered by two different systems as well. This is of course for redundancy in the case of an emergency of a hydraulic failure. I'm going to go over briefly how we can use these systems while the aircraft is running, just on the ground here. If you'll notice up here in the overhead panel you have a hydraulic system control panel where you have power for your primary and your demand systems. The primary systems are pumps that provide pressure at a constant rate, and they keep the hydraulic system primed at normal 3000 psi. The demand systems, on the other hand, provide extra power, extra pressure in cases of extreme use. Say, for example, you're putting your speed brakes out using a control surface and you have your flaps coming down. What happens is it detects a pressure drop and it will automatically kick in the demand pumps. Now you can turn on the demand pumps to run constantly, or you can switch them into the auto position, which lets them run only when they are on demand, as they're aptly named. We can bring up the ECAS display here, or excuse me, EFIS display, and we can demonstrate exactly what these systems will do. Okay, as you can see here, that we have the EFIS display, or the ECAS display, and we have the controls that control the engine, electric, and air hydraulic pumps here. I do not have my engines running at the moment, so I'm not going to demonstrate the engine hydraulic pumps, but each engine pump has an electric on-demand pump as well coupled to it. So for this scenario, you can actually see the hydraulic pressure coming up. So if I turn on the electric pumps, you'll see the hydraulic pressure of the middle system coming alive here, and all of a sudden you have pressure to your nose gear and steering, your brakes, alternate brakes, excuse me, your main gear steering, and your flaps and your flight controls. You can also see here that the air systems also power these primary systems as well. There are also electric pumps coupled to each engine pump. If I turn those on to auto, you'll see that since they detect a low pressure system, the demand pumps fire up, and you can see them light up, and now I've got hydraulic pressure to all my primary hydraulic systems. Additionally, I can turn on the air demand pumps, and you'll see since I'm on the ground and I'm not using much hydraulic pressure at the moment, you'll see that the air pumps will not come on, because it's sensing that there's enough pressure in the system that they do not need to come on. Now if I turn off the electric pumps in the center, you'll see the pressure starts dropping, and you'll see an air pump starts to take over. There you go, right there. Now if the engines are running, they're going to be powering the systems for flight controls on the outboard sides here. You'll see that during flight, the air and the electric pumps power most of the hydraulic systems in the aircraft, but all three are capable of running the aircraft on one system. I'll turn these off and show you that they indeed will all depressurize here. here they come down. Hydraulic pressure dropping. So basically that's all the information you need to know about the Boeing 777 hydraulic system. If you have any further questions about the hydraulic system, please review Flight Crew Operations Manual Volume 2 for the Boeing 777. We'll see you next time.